my name is Michael MacDonald. I am a system architect with the Logic E9 team in Milwaukee, and today I'm going to show you how to use the shear wave elastography option on the newest release of the Logic E9. It's important to remember that shear wave elastography is implemented on two probes on the Logic E9 for this release. Those two probes are the C1 to 6 and the 9L probe. Alright, to begin with, we will enter elastography mode. That is done via the button on the touch panel. It's important to recognize that the elastography button serves two functions currently. One is to enter strain elastography and the other is to enter shear wave elastography. So once we press this button, you'll see on the touch panel you have the option to either enter strain elastography or shear elastography. Since shear wave elastography was the last elastography mode used on this system, it defaults to shear wave elastography. If I wanted to go to strain elastography, I could press that button and you'll see the normal strain elastography touch panel appear. Now the purpose of what we're demonstrating right now is shear wave elastography, so I will return to the shear wave elastography touch panel. Now you'll notice on the image display I have a normal B mode image with a region of interest defined. The region of interest is the yellow box outlined within the B mode image. This is what we call shear wave pre-mode. Using the trackball, I can move the location of that region of interest within the B mode image. What will happen when we really enter shear wave elastography is the shear wave elastography information will be filled in within that region of interest. So if I see this lesion on the phantom, I can highlight part of that lesion. In this instance, the lesion is very large, so I cannot fit the entire region of interest over the lesion, but I will leave part of the region of interest outside and the normal phantom tissue, and part of the region of interest within the lesion. Now to enter the true shear wave elastography mode, you're going to want to use the right mouse button, which is labeled Start. So as soon as I hit the Start button, you'll see right away I have fill within the region of interest. Now since we are measuring within a phantom, there is a phantom button on the touch panel which I want to press so that I can optimize my settings just for measuring within a phantom. Obviously clinically that's not something that you'll normally use. So you'll notice now within the region of interest I have a dark red color for indicating stiff lesion material and yellow indicating slightly softer material. Another important piece of information to realize is the clock you see spinning in the upper right hand corner up here. This indicates how often we are updating the frame of shear wave elastography. So basically at noon a new frame will get updated on your display. If I press freeze, that will allow me to take measurements on the lesion that I just acquired information for. So pressing the measure button, I immediately get a display of another region of interest, and that allows me to position a small region of interest, a small circle within the larger shear wave region of interest. I want to move this particular circle right now because it is going to span both the hard lesion and the softer outside. So I will press the caliper button to position it out in the softer material, and then I will press set. As soon as I press set, you will notice that the velocity of the shear wave propagation is displayed as about 2.7 meters per second. Now I want to compare that with what's going on inside of the lesion, so I will place another cursor inside, and now press set, and then expand that a little bit, and press set again to get a measurement of about 4 meters per second inside the lesion. So we've allowed the users to position up to 12 different smaller regions of interest or circular ROIs within this exam. So I will not expand that to 12 for sake of keeping this short, but typically in a liver exam what the users want to do is, again, for liver, what they want to do is just measure a homogeneous section of the liver to get an idea of the degree of fibrotic tissue or basically the stiffness of the overall liver. They're not typically looking for lesions as we're seeing right here. So if I recall, for instance, a image on the clipboard, which happened to be demo images, you'll see much more of a typical use case for the liver. Here you see that the user has highlighted with the region of interest a very uniform section of the liver and has noticed that there's a pretty homogeneous fill within that region of interest. And the user would then go on to take measurements, up to 10 or 12 measurements with that very uniform fill. And that gives you an idea of the overall stiffness of the liver. Again, that's the liver case. The breast case will be very different. That is typically the case where you're looking for individual lesions. All right, so now I will explain how to use the 9L with shear wave elastography. Now I've selected the 9L probe, but it's very important to recognize that my previous model was the abdomen. So I want to use the 9L for breast, so I must choose a new model by pressing the model button, small parts, and breast is already selected. So if I press scan, now I should be set up to get much better images with a breast application. So using the same phantom, I now will find the lesions within this phantom. Let me decrease my depth a little bit, and there you can see the B mode outline of a lesion. So very similar to the C1 to 6, I will press the elastography button, and it will already know that my previous elastography mode was shear wave elastography, so it will automatically go into shear wave elastography. But the display, you'll notice, is a little bit different. Here we default to a side-by-side display, where the left side is the B mode image and the right side is what will be the shear wave elastography image. This is very similar to what we do in strain elastography, so we wanted to keep the workflow very similar. So seeing that the lesion is roughly highlighted by my region of interest, I will again press the start button, and right away you see that the lesion pops out on the right hand side. In fact, I will once again also press the phantom button, realizing that the tissue that I'm imaging here is a phantom, and you'll see that the lesion is very well defined and very well characterized by the shear wave propagation through that cyst. So once again you see the clock spinning in the upper right hand corner, indicating that you're transmitting frames, and our frame rate is about 1 frame per second. I will once again freeze, and you'll notice as soon as I hit measure now, it's a little bit different than the abdomen workflow. The reason being, the abdomen workflow, typically our users want to take multiple measurements within the region of interest. And we are thinking in the breast, that may not typically be their workflow. So we've defined a workflow where it's much more common for them just to take measurements of linear distance, or if they select velocity on the touch panel, they can again take a measurement of stiffness within the lesion. And we see here the velocity is about 4.6 meters per second. And also they can select stiffness, and you'll see that the stiffness measurement is about 65 kilopascals. I should also note that that option was available on the abdomen probe, the C1 to 6 as well. For liver, you can either measure in velocity, meters per second, or the stiffness in kilopascals. The choice is very much up to the user, and some users will only want to use meters per second, some users will only want to use kilopascals, but typically one user or one site will always use one or the other. So we've allowed the users to select which one they would prefer. And they can easily change between them if they would prefer. And that is, at a very high level, the basic operations of shear wave elastography on the Logic E9.